Newton's first law.
An object in motion or at rest tends to stay in motion or at rest unless acted on by an outside force. Now I gotta go see what my...
Okay, I'm going to demonstrate Newton's first law. First we have a cloth here and a book on top of it. I'm going to pull this cloth and the book is going to stay here because it's at rest and wants to stay at rest. So, here we go. Ready? Becky's going to demonstrate Newton's first law. Okay, she's feeling a little blonde today, so she's going to run into the wall and let's see what happens. Okay, the reason that Becky fell over after hitting the wall is because she was in motion and the outside force, the wall, acted on her.
Newton's second law.
The acceleration of an object depends on the mass of the object and the force applied to it.
Also, force is equal to mass times acceleration.
Okay, we're going to demonstrate Newton's second law. First, I'm going to push Becky. Now I'm going to push the wall with the same amount of force. The reason that Becky fell over and the wall didn't, even though I pushed him with the same amount of force, is because Becky has less mass than the wall.
And that's physics. Here's a demonstration of Newton's second law. Here we had two cars. The smaller one has less mass than the bigger one. I'm going to push them with the same amount of force. Okay, we see that the small one went further than the big one is because acceleration equals force divided by mass. Newton's third law.
Whenever a first object exerts a force on a second object, the second object exerts a force equal in magnitude and opposite in direction to the first object. Okay, Becky is going to demonstrate Newton's third law. She has two balls. The little one is less massive than the big one. So she's going to throw the first ball and let's see what happens. She only moved back a little bit. She exerted that much force on the ball, and so that's how much force the ball exerted back on her.
Go get it.
Okay, now she's going to throw an even bigger ball.
Look.
Let's see what happens now. The reason she was pushed back with so much force is because she had to exert so much force on the ball.
faster you push me, the farther I get. You're adding velocity. I will roll very far, but not as far as that car. Weight is such a central part of momentum still, whether you care or do not. Yeah, now if you don't mind, the faster you push me, the farther I get. You're adding velocity. The faster you push me,